Hi, this is Halal. In this video on mathematical economics series, we will discuss about the Marshallian demand function and Hicksian demand function, and see the difference between these two demand functions. Okay, so first we take the Marshallian demand function. It is also called the ordinary demand function. Okay, this Marshallian demand function is also called the ordinary demand function, and it actually traces the relationship between demand of a good and its price holding the nominal income constant. So I will write here it traces the relationship between demand demand of a good, let us say X, and its price holding nominal income constant. Okay, what does this mean? The Marshallian demand function simply says that demand for a good depends upon its price. Okay, and we held other things constant that might have affected the demand, what we call the ceteris paribus. Other things could be the the tastes, preferences, the price of other goods. Okay, so the Marshallian demand or ordinary demand function would look like this. That is, a demand for, let us say, good X is the function of price. Okay, so it actually traces the relationship between the demand for good X and its price holding the nominal income constant. This is the main essence of this Marshallian demand function. So with a given budget, we want to study the relationship between demand of a particular good and its price. Okay, so this price effect in the Marshallian demand function can be decomposed into two effects, that is the income effect and substitution effect. So I will show you how do we do that. Suppose, let us say, price of a good, let us say price of good X has decreased. Okay, that would mean the real income, that is denoted by y. If this y denotes the income, divided by p, so this will increase. That means if price of a good decreases, consumers real income would increase. That is, I will write here real income increases. With this real income when increases, that simply means demand of this good will increase. Okay, if price decreases, real income of the consumer will increase. Obviously, that means with decrease in the price, demand for the good will increase, and this is called the income effect. Okay, so I will give an example. Let us say price of good X was 10, to show how the income effect actually works, and income of the consumer was 100. Okay, with 100 as the income and price of good X as 10, then quantity demanded would be equal to 100 divided by 10, which means he can buy 10 goods. Okay, now let us say price of X has decreased to 5. Okay, then if the price of good has decreased, nominal income will remain same. Okay, but real income will change. How? Because with same $100 or rupees, quantity demanded would increase. 100 divided by, since price has decreased from 10 to 5, we can demand 20 units of good X. Although the nominal income is same, but real income has increased. Okay, so this is the income effect. Okay, if the price of a good decreases, with that the consumer's real income will increase, and subsequently this will mean demand for the good will increase, and this is called the income effect. So ordinary demand function contains the income effect, and I have told you, shown you an example how this income effect works. Let us say the demand, the price of good was 10, income was 100. With 100 as income and 10 the price of the good X, we can demand 10 units of uh, good X. But if the price has decreased, uh, real income has increased. I will write here, real income has increased because this same 100 rupee, sorry, this same 100 rupee can now actually buy us 20 units compared to the 10 units that was previously demanded. Okay, so with decrease in price, consumers real income will increase, and consequently demand for the good will increase. Okay, so this is the income effect. Similarly, uh, another effect that comes in place in the Marshallian demand function is the substitution effect. That is substitution effect. So how does it actually work? So let us say the same good we have. Let us say price of good has, price of X has decreased. Okay, price of a product has decreased. Now this will simply mean that consumer can substitute a good X for any other good, let us say Y. That is, consumer can substitute X for Y. That means X is cheaper than Y. So I will write here X is cheaper than Y. Okay, so when the price of good decreases, so the consumer can substitute X for Y, uh, because now X is comparatively cheaper than other goods. In case in here it is Y, so X becomes cheaper than Y comparative to Y. So this means when price decreases, demand for X will increase. Okay, so this is the substitution effect. This ordinary demand function, the price effect in the ordinary demand function, is composed of the substitution effect and also that of the income effect. Okay, this is the main essence of the Marshallian demand function. Okay, so substitution effect, you can easily comprehend this. When the price of good decreases, this same good becomes cheaper than the other good, so obviously demand for that good will increase. Okay, so the price effect in the ordinary demand function is composed of, price effect is composed of income effect plus substitution effect. Okay, so we can also say ordinary demand function is a problem of maximization. So I will rub this. Now we can also say that this Marshallian demand function or ordinary demand function is a problem of maximization. That means what we do with given income, we want to maximize utility. With given budget line, consumer wants to reach the higher indifference curve. Let us say we have this graph. Let us say this is X and this is product Y, and we have the budget constraint also here given. So in the ordinary demand function, with given budget constraint, the consumer wants to reach the higher indifference curve. Okay, from IC1 to IC2. So in case of the ordinary demand function, since the budget is rather the income is constant, the consumer wants to reach the higher indifference curve. So we are given the budget and the consumer wants to reach the higher indifference curve. That means with given income we want to maximize the utility. Okay, so I will write with given income, consumer consumer wants to maximize utility. What we can say here, that is, given the budget, consumer wants to maximize its utility. By maximization of utility, we mean the consumer wants to reach to the higher indifference curve. Okay, so we are given the budget line and consumer wants to reach the higher indifference curve. So this is also called this is the case of the maximization. So we want to maximize utility, so I will write we want to maximize utility subject to the budget constraint. Let us say uh, p1 x1 plus p2 x2. Okay, maximize utility, let us say x1 and x2. So with given budget or with given income, consumer wants to reach the highest indifference curve, or we want to maximize the utility. Okay, so two effects take place in case of the Marshallian demand, or what we call the ordinary demand function. So to make this video more useful, I should in parallel tell you what is the Hicksian demand function and what is the difference between these two functions to get a better idea about these two demand functions. Okay, I hope I am making myself clear. So in case of ordinary demand function, what we see, where the ordinary demand function traces the relationship between demand of a good and its price holding nominal income constant. But in the Hicksian demand function, it traces the relationship between the price of a good and quantity purchased holding other price and utility constant. Here we hold the utility constant and trace the relationship between quantity demanded uh, and the price. So I will write here, this Hicksian demand is also called the compensated demand function. So I will write here compensated demand function. Okay, so what does this tell us? It traces the relation, so I will write here traces the relationship between uh, a relationship between price of good let us say x, and quantity demanded holding holding other prices and utility constant. Now what does this mean? This sorry Oh, okay. Now, what does this mean? Hicksian demand function or compensated demand function simply means we trace the relationship between price of a good and quantity demanded. In this case, we hold the utility constant. In the Marshallian demand function, we hold the nominal income of the uh, consumer constant. Although we allow the real income to vary, as I have told you with an example. So in case of compensated demand function, how does this compensated term comes in this demand function? It simply says we compensate a consumer for any change in price, depending whether the price increases or decreases. So I will try to make it more clear. Let us say the price of a good, let us say price of a good X has decreases. Okay, if the price of good decreases, the real income, which is y by p, will increase. In this case, we will impose tax so that the real income remains same. So the real income y divided by p remains same. Okay, or what we call the utility remains constant. Okay, so if the price of good decreases, real income will increase. In this case, we will impose tax so that we are back with the given real income. That means the utility remains constant. Similarly, if price of good increases, then real income of the consumer will decrease. In this case, we can do one thing: we can subsidize, or we can give subsidy so that this real income of the consumer remains same. Okay, or what we call utility remains same. Okay, so we compensate. The basic idea about the compensated demand curve is we compensate a consumer for any change in the price, depending whether the price increases or decreases. If the price decreases, we impose tax so that real income remains same or utility remains same. And if the price increases, with increase in price, the real income will decrease. In this case, we can give the subsidy so that real income remains the same or the utility remains same. Okay, so in this case, income effect has no role because the real income remains the same. So income effect in the compensated demand function doesn't have any role. So I will write here uh, income effect has no role in compensated demand function. Okay, so but the substitution effect will always play its role. That is, if price of the good has decreased, consumer can substitute x for y. That is, substitute x for y. Let us say y is another good. Okay, holding his what we say his real income remains constant. As I have told you, if price decreases, consumer can substitute x for y because x is now relatively cheaper than y. So with decrease in price, consumer can substitute x for y, which means demand for good will increase. Demand for the product will increase. That means substitution effect will uh, rather the substitution effect will take place in the compensated demand function. The basic difference is this: in the in the Marshallian demand function, two effects take place. That is income effect and the substitution effect. But in the Hicksian demand function, only the substitution effect takes place because the income effect has no role because we don't allow the consumer's real income to change. If it changes, we impose tax so that the consumer's utility remains same. And if there is a decrease in the if there is decrease in the real income of the consumer, in that case we can give the subsidy to the consumer so that he has the same real income or utility remains constant. So we can say that this compensated demand function is the case of minimization. This is the problem of minimization. Okay, What does this mean? By the problem of minimization, we mean we are given utility is given, or utility remains same. The consumer wants to minimize its costs. Okay, the consumer wants to minimize its cost so that the utility remains same. In this case, in the Hicksian demand function, what is we this utility is given, and the consumer wants to buy the good with the minimum possible expenditure. Okay, so here the utility is given and consumer want to minimize its cost. In the Marshallian demand function, our budget line or income was given, and the consumer in this case tries to reach the higher indifference curve. And in this what we call the Hicksian demand function, we are given the indifference curve or utility, and consumer wants to purchase this utility, this the goods with minimum amount of expenditure. Okay, so this is the problem of minimization, and the Marshallian demand function is the problem of maximization. Okay, I hope I am making myself clear. So I will graphically try to show what is the difference between uh, the Marshallian demand function and the Hicksian demand function. Okay, so let me draw a graph. Okay, let us say we have quantity demanded on this axis and price of the good on this axis. Okay, this is O. Okay, now let us I will draw two demand curves. This is the Marshallian demand function demand curve, and this the Hicksian demand curve. Okay, let us say initially the price was OP, and quantity demanded on both curves was X. So with OP as price, consumer can demand OX of the quantity. Okay. Now let us say the price has decreased from P to P1. Let us say price has decreased to P1. If the price decreases to P1, what will happen in this case? We can see here, we can see when the price decreases from P to P1, uh, on the Hicksian demand curve, we have this very intersecting point. Let us say this is X1. When the price has decreased from P to P1 on the Hicksian demand curve, only this OX1 is demanded. Okay, but with same decrease in price, consumer can demand, let us say this is X2 here, consumer can demand OX2 of the OX2 of the commodity. Why? Because as I have told you, in the Marshallian demand function, two effects take place, that is income effect plus substitution effect. Okay, but on the Hicksian demand function, only substitution effect takes place. So that means this Marshallian demand function is more price elastic than that of the Hicksian demand function. That is, I can write elasticity of demand in case of the ordinary demand function would be greater than uh, the elasticity of demand in case of a compensated demand function. Why? Because in the ordinary demand function or Marshallian demand function, both substitution effect and income effect takes place. Okay, but in case of the compensated demand, only substitution effect takes place. That is why this Marshallian demand function is more, rather the marginal demand curve is more price elastic than that of the compensated demand function. We can see here two effects takes place. Let us say substitution effect was 5 and income effect was, let us say, 5. But in case of ordinary demand compensated demand function, let us say substitution effect was only 5. So we can see here the price effect in case of Marshallian demand is greater than that of the compensated demand function. Okay, I hope I am making myself clear. Now, coming to the important property of the Marshallian demand function and ordinary demand function, that is the homogeneity of these two demand functions. This Marshallian demand function is homogeneous of degree 0. That is, Marshallian demand function is homogeneous of uh, degree 0, 0 in both prices, both price, both prices and income. What does this mean? So for that, we will take the example how to derive the Marshallian demand function. Okay, so as I have told that the Marshallian demand function is actually the problem of maximization. That is, we want to maximize utility. Let us say x1 and x2 are the two goods. We want to maximize our utility subject to the budget constraint. Let us say we have the budget constraint, that is p1 x1 plus p2 x2 is equal to m, where p1 and p2 are the prices of x1 and x2, and m is the income of the consumer when he spends all his income on these two goods. Okay, so to show the homogeneity, what we will do, we will first derive the Marshallian demand function. So we have the optimization problem. We want to maximize our utility subject to the budget constraint. That is, we want to reach the higher independence curve, that is maximizing the utility with given level of income. Okay, so how do we solve the utility the constraint optimization problems I have shown in earlier videos? So I will just use that very concept here. First, if this is our utility function, we call this very function which we want to maximize objective function, this is called the constraint. Okay, so first we form the Lagrange's function. Lagrange's function is formed by before forming the Lagrange's function, what we do, we set this constraint equal to 0 and multiply it by lambda. That is what we do. We will write m minus p1 x1 minus p2 x2 is equal to 0, and we multiply it by lambda. Okay, so then we form the Lagrange's function. Lagrange's function is simply formed by then Lagrange's function is formed by adding the objective function and the resulting constraint. uh, okay, so our objective function is this x1 x2 plus this very resulting constraint, this is lambda m minus p1 x1 minus p2 x2. Okay, so this is our Lagrange's function. After that, we partially differentiate with respect to x1 and x2 and set them equal to 0 simultaneously. So partially differentiating, this will become L x1. We partially differentiate this very Lagrange's function. So here x1 would become 0, derivative of x1 would be 1. So this is here x2 minus the derivative of x1 would be here 1, derivative of x2, because it is constant here, we are partially differentiating, so here we will get only lambda p1 and we set it equal to 0. Similarly, we partially differentiate with respect to x2. So in this case, this x2 will become 1. So we are with this x1 minus lambda. Here the derivative of x2 is 1. So we are left with p2 and set it equal to 0. After that, we let us say this is equation first and second. We divide equation first by second. Okay, what we will get here, we are with this x2 divided by x1. Okay, when transposing these on RHS, this will become lambda p1 divided by lambda p2. This lambda gets cancelled. We are left with this x2 is equal to p1 divided by p2 times x1. Okay, by simple manipulation we get this result. This is also called the angel curve. Okay, so what we will do, we took this very relation, this very equation, and put it into the constraint function. Okay, so put this value in this very equation. So we are with this p1 x1 plus p2. In place of x2 we have p1 divided by p2 times x1, which is equal to m. Okay, so this p2 gets cancelled. We are left with p1 x1 plus p1 x1 is equal to m. Okay, or this is p1 x1 is equal to twice p1 x1 is equal to m, or x1 is equal to m divided by twice p1. Okay, so this is our Marshallian demand function, which is the function of income and price. So it traces the relationship between quantity demanded of x1 and price of x1, holding the money income constant. Okay, so here we will see what does the homogeneity of 0 means. It simply means if we increase money income and price in the same proportion, quantity demanded will not change. Okay, there would be no change in the quantity demanded if income and price change in the same proportion. That is, if we double the income and the price, quantity demanded will remain same. Okay, so let's take an example. Take an example. Let us say price p1 is equal to 1, price of 2, x2 is equal to 2, and initially we are given the income of 100. So if we put these values here, so x1 would be equal to m, which is 100, divided by 2 times the price of x1 is p1, which is 1. So it is 100 divided by 2, which is equal to 50. Okay, now if we double the income, if we double the parameters, let us say if we double the prices, so if it is p1 is equal to 1, so I will write if we double these things, so p1 would become 2, p2 would become 4, and m would become 200. Okay, then what would be our quantity demanded? So quantity demanded would be equal to x1 is equal to m is 200 divided by 2 times the price, new price is 2, and here we can see 200 divided by 4, which is equal to 4 5s are 20. So we can see if we change the income and the price in the same proportion, quantity demanded would not change. It is same 50 which we got earlier. This is called homogeneity, homogeneous of degree 0, and the Marshallian demand function is homogeneous of degree 0. That simply means if we double the income and price, quantity demanded will not change. Okay, so This was about the Marshallian demand function. Similarly, I have only derived for x1. You can derive for x2 also. So for x2, it would be simply x2 would be equal to m divided by twice p2. Because of the lack of the space of the time, I will not be able to derive. You can easily derive this. Okay. Now coming to the Hicksian demand function. Since the Marshallian demand function was a problem of maximization, Hicksian demand function, as I have told you earlier, is the problem of minimization. We want to minimize our expenditure to reach the given utility. Okay, so I will show. Now coming to the Hicksian demand function. Hicksian demand function is homogeneous. So I will write homogeneous of degree 0 in price only. Okay. um, Marshallian demand function was homogeneous of degree 0 in price and income, but the Hicksian demand function is homogeneous of degree 0 in price alone, in prices alone. Okay, so I will show you how do we do. In this case, we want to minimize, as I told, the Hicksian demand function is actually the problem of minimization. We want to minimize our expenditure. Let us say we are given p1 x1 plus p2 x2 subject to the utility x1 times x2. So we want to minimize our cost to achieve the this constant utility. This is the minimization problem. So as I have derived earlier, so I will derive here also. The Hicksian demand function would look like this. First, this is our objective function. This is the constraint here. Okay, so first we set this constraint equal to 0, that is u minus x1 x2 is equal to 0. After that we multiply it by lambda, and after that we form the Lagrange's function by adding the objective function and this resulting constraint function. So this will become p1 x1 plus p2 x2 plus lambda u minus x1 x2. Okay, now we partially differentiate this Lagrange's function with respect to x1 x2 and set them equal to 0 simultaneously, because this is the first order condition, and we know that the tangency between the indifference curve and the budget constraint is the optimal bundle. That is why we set it equal to 0. So partially differentiating with respect to x1 will give us here we are left with p1 only, because x1 would be equal to 1, plus, since no x1 is involved here x1 would become 1, so we are left with, so I will write here, this will become minus lambda x2 is equal to 0. Similarly, L x2 would become, we differentiating with respect to x2, so this will become 0. Here the derivative of x2 is 1, so this will become p2 minus lambda. Here x1 x2 will become 1, so we are with this minus lambda x1 is equal to 0. This is equation first, and second we divide these two, we are left with p1 divided by p2. Transposing these two would become, this will become positive, lambda x2 divided by lambda x1. This will get cancelled, and we are left with x2 would be equal to, x2 is equal to simply p1 divided by p1 divided by p2 times this x1. When transposing, this will get multiplied, so this is x1. So this is our angel curve. We put this angel curve in the constraint function, okay, to get the Hicksian demand curve. So put this in the constraint function, so we are left with u is equal to x1 times x2. In place of x2 we have p1 divided by p2, sorry, it is here p2 times x1. Okay, or this becomes u is equal to x1 square times p1 divided by p2, or we can write x x1 square x1 square is equal to x1 square is equal to we transpose p1 p2 here, so this will become u times p2 divided by p1, or we can write x1 is equal to under root of u into p2 divided by p1. Okay, this is our Hicksian demand function, which is the function of price only here, ratio of the prices here we can see. Now by homogeneous of degree 0 in prices means that if we change the prices in the same proportion, demand will not change, demand will remain the same. That is, let us say we are given price of p1, price of good 1 is 4, price of good 2 is 16. Sorry, let us make it clear here, so I will rub this. Let us say price of x1 is equal to let us say it is 2, price of good 2 is 8. Since utility is constant, we hold utility constant, we will not write anything here. So our demand would be equal to, which is under root u times under root p2 is 8, p1 is 2. So we are left with under root u times, now this is 2 ones are 2 fours are, now 4 will become 2 square, so this will get cancelled, so we are left with 2 under root u. So this is our quantity demanded when price of good 1 was 2 and price of good second was 8. Now if we double, that is, if we change the prices in the same proportion, if we double the prices, so p1 would become 4, p2 would become 16. Now then our demand would become, that is u times p2 is 16, so I will write here 16 divided by p1 is 4, so here we can see it is same, this is u times 4 ones are 4 fours are 16. Now 4 square is 2 square, or rather I will write here this is 2 square, this will get cancelled, so we are back with the same thing. That is, if the prices change in the same proportion, quantity demanded will not change. This is what we mean by homogeneous of degree 0. So I will summarize here what are the differences between Marshallian and Hicksian demand function. So let me summarize this. In case of Marshallian demand function, what we do, we trace the relationship between demand of good X and its price holding nominal income constant. Okay, in case of Hicksian demand function, we trace the relationship between demand of X, which is a good, and quantity demanded holding prices and utility constant. Okay, this is the first difference. Second, difference is that ordinary demand function is more. So first, before I will write here, in case of Marshallian demand function, substitution effect and income effect take place, but here only income effect takes place. That means ordinary demand function is more price elastic, price elastic, and this compensated demand function. Compensated demand function is less price elastic. Okay. Another difference is that in case of Marshallian demand function, Marshallian demand function or ordinary demand function is homogeneous of degree 0 in both prices and income, but compensated demand function is homogeneous in homogeneous of degree 0 in prices only. Another difference we can pick out, which we have discussed, that this Marshallian demand function is the problem of maximization, and this compensated demand function is problem of minimization. That is, we want to maximize our utility holding the budget nominal income constant. In case of this compensated demand function, we hold the utility constant and we want to minimize our expenditure. I hope I make myself clear in this video. If you like this video, please share and subscribe.